Good morning, everyone. Welcome to Tech Tuesday. So, the idea behind Tech Tuesday is very simple. In a week, we take out 30 minutes out of our schedule to discuss how AI and how technology actually works and how we implement it in our real-time cases. Okay, so today's session is actually, divided into two parts. In the first part, Akshit will let us know a simple and basic understanding on AI, what AI is in a simple words. And in the second part, in the second session, Lavenya will share us some basic insights that how this particular AI is used in real world. So to start with, we will have a short presentation followed by a Q&A session. So feel free to just note down the questions as we go. So I would like to invite Akshit to start with. So Akshit will first share us the basic idea about what AI is, followed by how machines learn to make decisions on their own. So this would be our key topic that we would be discussing today. Over to you, Akshit.
Thank you, Nilomi, for the warm introduction. Good morning, everyone. My name is Akshit Yadav. I am the analyst, AI MLM development at Hex Wireless. So I welcome you all for the first Tech Tuesday. Thank you all for coming. And let's begin the session. So today's topic is what is AI, how machines learn to make decisions. This is the first topic. After that, Lavenya will take over from me to explain a real world AI use case that is spam detection. So what is AI? Before answering this question, another question that comes into my mind is, why are we even talking about AI? Right. I'm pretty sure everyone sitting in this room have heard about what is AI and have a brief idea of what it is and how it works. So why are we even talking about AI? AI is rapidly becoming part of our daily lives. Everybody here uses ChatGPT, Gemini, Grok, or Claude Code in some sort of the other way, right? And ChatGPT came in 2022. With that came the boom of data as well as compute. It exploded, right? Coding emerged as the top AI use case. I'm pretty sure my developer friends here sitting here have used Claude Code or any other coding tool, for example. Why did it become successful? So there is a very specific reason why it became successful. The reason being that the AI which we interact, a major chunk of it is in the form of LLMs. LLMs, in simple words, is you ask a question and it responds it responds an answer, and the mode of that answer is text. The question in which you ask, the mode in which you ask is text, right? So how does this text get processed, right? So we will look forward about the underlying architecture and all of that, and after that we have that AI impacts revenue, customers, and trust. It is proven to increase productivity at work, right? What is artificial intelligence? Artificial intelligence is technology that enables computers and machines to simulate human learning, decision making, problem solving, creativity, and autonomy. This is the definition I took from IBM's website. What I really wanted to talk about today is what I really understand from AI. So researchers have been researching from the 1950s on AI and machine learning. And the major significant breakthroughs which they had was because they tend to find a mapping, or there is a term called biomimicry, in which they tend to gain experience or tend to gain inference from the way humans think, act, or behave in their surroundings. So, simple example, let's take the example of, let's say, ChatGPT, right? It is a form of textual communication, right? So, what basically differentiates a human from a machine? A human has some special features, or we can say organs. We have organs. We have the brain. We have the heart. Humans have conscience. Humans have soul. But the AI doesn't have any of that. What AI lacks is, or rather, a better question would be, what does AI have? AI has, it understands well from patterns. it cannot really do well on unseen data, right? So a machine, on the other hand, doesn't have special abilities, as I said. So how do we make it smart? The basic answer lies in two words, that is numbers and compute. What I mean by that is ChatGPT, Grok, Gemini. All these words, AI doesn't understand English language, as we know, which is a very logical interpretation. But what it understands better is numbers. And so what we do is basically the English language, the letters which we see, which we input into ChatGPT, they are converted into vectors. Vectors are basically a set of numbers. And how are these numbers formed, right? So basically, what the AI does is it forms a correlation mapping. Correlation is nothing but if you see two words such as artificial and intelligence, there is a high probability that after artificial, the word intelligence would come. So higher the probability of a word occurring after another word, higher the correlation coefficient. So in order to store that, we have vectors. These vectors are then further stored in embeddings. These embeddings are further trained with the AI model, right? Then we have another example I would like to give is the example of images. You all must have used Nano Banana or DALI or the latest Gemini image models, whether it be to make a Ghibli image or um, use it as an editing tool or Google or Gemini, etc. So these are all examples of computer vision. Computer vision is a part of AI in which we enable the computer to um, behave as if it is seeing an image. But as we know that a computer doesn't have eyes, so how do they perform it, right? How do they make it perform? So what we do is basically if you have an image, let us see, for example, this is the image. Each image that has pixels, as we know, these pixels are converted into grayscale. Grayscale is nothing but if I had to convert this colored image into a black and white image. So after that, I will take a small chunk of that image. Each chunk consists of pixels, and each pixel has a numerical value ranging from 0 to 255. 0 stands for white, 255 is black, and in between all is gray, right? So again, numbers. So you guys must have gained a certain idea, like AI usually works well with numbers. But in the case of images, it is pretty different from text. Different in the sense that images usually, as we can see, every single pixel stores a certain amount of numbers, hundreds of numbers. These numbers are stored in a vector of n dimensions. There are many dimensions. So if I consider this image, there might be trillion numbers which we are dealing with. So image compute is typically more complex or more compute heavy than textual compute, right? So not going into the technical details, let us move forward. How machines learn to make decisions. Machine learn from examples. Machine tries to find patterns. As I said before, machines practice and improve. They make decisions using probability. Next one is, so what is the difference between traditional software and AI? So traditional software mainly involves rule-based learning, or and AI in comparison offers learning-based. So rule-based means, let us take the example of spam detection. In spam detection, for example, if I write a certain chunk of code, for example, such as I'm inputting these two words, free and lottery. अगर free और lottery किसी एक spam किसी message में आता है, then I will classify it as spam और spam दे देना उसको, right? But उसमें क्या होता है फिर कि for example अगर free word जो है उसमें अगर person e के बजाय 3 लिख दे, या फिर a character he replaces it with at the rate, then the logic fails. So instead of that, what happens in AI is it is more learning based. What we do is we provide a set of messages. These messages consist both spam and ham messages, ham meaning not spam. And we basically give it to the model. We are like, hey, take these messages and try to understand the patterns, try to draw the patterns, right? And whenever you get a new message, try to classify based on what you have learned. Then comes fixed logic versus adaptive behavior. AI is much more adaptive. For example, अगर आपको piece of code को change करना है किसी और तरीके से behave करने के लिए, then you have to take a certain amount of time in forming a new logic, etc. But in AI is pretty adaptive. What does AI say is it behaves a little bit like human. आप उसको new messages दें. For example, in the case of spam detection, you give it new messages. Then it will say कि okay, now I have learned new more patterns. So बस मेरे को retrain कर दो and then deploy me. I will behave much better than before. So where AI is used in business, fraud detection mainly uses unsupervised learning. Then unsupervised learning meaning कि मैं AI को बोलता हूँ कि मेरे पास कुछ इन्फॉर्मेशन मैं आपको दे रहा हूँ, बट मेरे को क्या पैटर्न्स ढूंढना है मैं वो नहीं बता रहा हूँ. आप मेरे को बताओ कि क्या क्या पैटर्न्स निकल के आ रहे हैं. सो फ्रॉड डिटेक्शन इज अ वेरी गुड एग्जांपल बिकॉज फ्रॉड करने के बहुत सारे तरीके होते हैं. मैं ऐसा नहीं बोल सकता AI को कि मेरे को ये मैं आपको बोल रहा हूँ कि यही फ्रॉड है. आई एम गिविंग इट certain things or certain data and I'm saying कि draw out some patterns from it. Then comes spam detection, as I said before. Spam detection involves giving the model a set of spam and ham messages. Then we have customer support. Customer support is one thing which is gaining rapid development, especially in the case of AI. In the sense कि, for example, first of all, हर एक कंपनी के एक वेबसाइट पेज पे एक चैट ऑप्शन रहता है. So, for example, Zomato में आप लोगों ने देखा होगा, you guys must have seen कि customer support जब भी आता है, there is an option कि there is an AI part. After that, customer executive takes over from that. अगर आपको query satisfy नहीं होती. So, another point which I wanted to discuss is psychophancy. Some key AI takeaways. AI learns from experience at scale. As I said, जितना ज़्यादा data आप AI को दोगे, उतना ज़्यादा वो learn करेगा. After that, AI proves to be exceptional at certain tasks, but not everything. Psychophancy is a term which is used nowadays. अगर आप लोग ने सुना होगा. Psychophancy is basically AI trying to flatter you, या फिर AI trying to give you results in order to please you, rather than being factually correct. So उससे क्या होता है कि basically the goals which you are trying to achieve or the correct answer which you are trying to achieve does not come to you. For example, currently we were developing a chatbot as an example for just a POC for the training school. So what questions which were very detail oriented, it was always saying yes. Even if the answer was no, it was saying yes. So that is a case of psychophancy where AI fails to provide accuracy in certain problems. So that is one thing you should watch out for. And you should always remember whenever you are chatting with AI tools such as Analyst, ChatGPT or Claude, one thing to keep in mind is the AI is also trained upon certain amount of data, and it cannot perform always to the maximum accuracy because it is trained upon a certain amount of data. For example, आज X wireless में text use जो हो रहा है वो ChatGPT नहीं बता सकता. So that is the thing. And that's it from my side. Thank you.
Thank you, Akshit, for sharing us the great foundation. And it really helped us to, set up the context. So now that we are aware of the basic details of what AI is, so now let's look at the real world use case with Lavenya.
Now, before we understand the role of AI in spam detection, let's understand why do we even need spam detection. So over the past few years, the global adoption of digital communications has led to an even increased amount of spam SMS that is sent to users. And with billions of messages sent daily, spam is not just annoying, but it's also a security and trust issue. From a business perspective, spam detection is directly related to customer trust. Exposing our users to a fraudulent and poor experience gives them a poor experience, which eventually leads to declining customer trust and business value. Now, as all of you know, we already do have a spam filter, but why do we need a new AI-based system? So the reason is that the traditional spam filters use predefined rules like blocking some specific spam keywords or patterns. But the thing is that scammers and their scamming techniques are evolving daily. And using a predefined system like a traditional spam filter is not efficient, as the scammers can easily bypass the system and it's not very scalable. Hence, we use AI for that. Why? Because AI does not depend on fixed rules. It learns from data and improves and evolves over time. Okay. So now the question is, why do we need AI for spam detection? Like humans can do the task as well, right? Well, that is true. Humans can do the spam detection task, and that too quite well, even better than AI, but not at a massive scale. With billions of messages being sent every day, manually labeling the SMS is not an efficient solution. That's why we need AI, because AI is highly scalable. Like if you need to classify a lot of SMS in just a few minutes, AI can do that easily, which obviously is not possible for humans. And the second reason is consistency. Now let's assume that we have 5,000 SMS that we need to classify. Now, that is not a task that is very feasible for a single human. So we form a group of 5 people, and we ask all of them to divide the task and label those SMS. After that, when we see at those labels, we will find a lot of inconsistency, because every human has their own interpretation. For you, what might be scam, that might not be a scam SMS for me. And that is a problem that AI can solve very easily. So now let's see the spam detection flow. So first of all, the SMS enters our spam detection system, and then it goes through a pre-processing step. And this is a very important step, as our machine learning models cannot understand human languages like Hindi or English. So we need to convert those incoming SMS into a format that our machine learning model can understand, like converting those English SMS to a vector-based SMS. Then that SMS is passed as input to the ML model, and then our machine learning model has already been trained on the given spam and not spam data set, and then it gives a score as an output. So that score value is actually a number between 0 to 1, which basically gives the probability of the SMS being scammed. Then the decision part is actually user based. Usually the threshold is set to 0.5, meaning that if the spam score comes out to be more than 0.5, then the SMS will be labeled as a spam. Otherwise, it will be labeled as not spam. But this is completely user dependent. For example, if you want a stricter filter, then you can set the threshold as 0.3 or 0.4, depending on your use case. Well, now we will give a quick demo of our filter. So this is the spam filter that we've built so far, wherein we'll basically enter our SMS, and on clicking classify, it will classify our message as spam or ham. So these are a few sample messages. Let's take this one. So this is actually a spam message. Let's see how our model will classify it. So as you can see, the model has classified it as a spam message, and this 99.84 is the confidence that the model is so sure that this message is a spam SMS. Now we'll try it with a ham SMS, like this one. So this is a ham SMS. Let's see how our model classifies it. So yeah, it has classified our SMS as a ham message. So this was a demo of the model that we've built so far.
Akshit and Lavenya for sharing us the foundation and the real-world use cases. So with this, we come to an end of today's Tech Tuesday. So if this session sparked a little bit curiosity, then it is game for us. So see you next Tuesday with some more interesting. Thank you very much.